Hello everyone. Let us continue the second part of today's class. Okay, let us continue the first part. Okay, so C out Q is equal to log 2 of 1 plus rho times P inverse of Q and R. Okay, and this equation is equal to natural log of 1 plus rho times P inverse of Q and R over natural log 2. Okay, this completes the solution of to this problem. Okay, let us go back to the slides of chapter 3. Okay, so we have derived equation 3.60. Okay, it should be noted that equation 3.60, okay, this equation, okay, can be evaluated using the built-in MATLAB function called gamma incinv parentheses to solve for P inverse of Q and R. As a final comment regarding outage capacity, it should be noted that there is a difference between a MIMO system's outage capacity and the theoretical maximum throughput that can be achieved. The reason is that C out Q only occurs 1 minus Q% of the time. So the throughput RQ associated with C out Q is given by RQ is equal to 1 minus Q times C out Q. Okay. Okay, so next are the problems of this chapter. Okay, we have seen this. Okay. Okay, so we have finished teaching chapter 3. Okay, so let us see homework 3 of chapter 3. Okay, so the date of assignment is today, May 16th, 2022. And the deadline is May 23rd, 2022. Okay. There is only one problem in this homework. Okay. Write a program called ergodic capacity that computes the ergodic capacity C of a general NT by NR MIMO system with CSIR. If using MATLAB, the function should have the following form. Okay, C is equal to ergodic capacity of SNR dB, NT, NR, NITR, where SNR dB specifies the SNR in dB, NT and NR are the number of transmit and receive antennas respectively, and NITER is the number of Monte Carlo iterations used to estimate the ergodic capacity. Use this program to duplicate the curves in figures 3.6, 3.7, and 3.8. Okay, 100 points. Okay, let us see these three figures. Okay, first is figure 3.6. Okay, so this figure. Okay, so figure 3.6 is the ergodic capacity of an 1 by NR SIMO system in Rayleigh fading. And figure 3.7 is ergodic capacity of an NT by 1 meso system in Rayleigh fading. Figure 3.8 is ergodic capacity of an N by N MIMO system in Rayleigh fading. Okay. Let us go back to the homework 3. Okay, notice first, I encourage you to discuss with other people. However, if you copy someone else's homework solution or you borrow your homework solution to someone else for him/her to copy, your score will be 0. Second, you shall not copy the solution from any references. For example, the official solution manual. If you do this, your score will be 0. Third, if you hand in your homework after the deadline, your score will be 0. Fourth, please email your homework solution to Professor Wei-Zhen Liu. His email address is comwcliu@ccu.edu.tw. Okay, that's all about homework 3. Okay, next let us see some new announcements. Okay, the first new announcement is the slides of chapter 4 has been updated, version 2022-0514. Hello everyone, I have uploaded the latest version of the slides of chapter 4 to the eCourse 2 website. The location and the file name are eCourse 2 website, multiple input, multiple output techniques for wireless communications, course content, slides, chapter 4, slides 2022-0514.pptx. Best regards, Wei-Zhen. Okay. The next new announcement is the handout of chapter 4 has been updated, version 2022-0514. Hello everyone, I have uploaded the latest version of the handout of chapter 4 to the eCourse 2 website. The location and the file name are eCourse 2 website, multiple input, multiple output techniques for wireless communications, course content, handouts, chapter 4, handout 2022-0514.pdf. Best regards, Wei-Zhen. Okay, the last new announcement is homework 3 problem has been uploaded. Hello everyone, I have uploaded the problem of homework 3 to the eCourse 2 website. The location and the file name are eCourse 2 website, multiple input, multiple output techniques for wireless communications, course content, homework 3 problem 2022-0513.pdf. Best regards, Wei-Zhen. Okay, next we will teach chapter 4. Please open the slides of chapter 4. Okay, and turn to page 1. Okay, chapter 4 is RF propagation. Okay, what is RF? Okay, let us see the handout. Okay. Okay, page 1, problem 1. What is RF? Solution. Radio frequency RF is the oscillation rate of an alternating electric current or voltage, or of a magnetic, electric or electromagnetic field or mechanical system in the frequency range from around 20 kHz to around 300 GHz. Okay, I think you already know what is kilohertz. Okay, 1 kilohertz is equal to 1000 hertz, and 1 gigahertz is equal to 10 to the power of 9 hertz. Okay, this is roughly between the upper limit of audio frequencies and the lower limit of infrared frequencies. These are the frequencies at which energy from an oscillating current can radiate off a conductor into space as radio waves. Different sources specify different upper and lower bounds for the frequency range. Okay, this is RF. Okay, next let us see the outline of this chapter. Okay, first we will introduce phenomenology. Okay, what is phenomenology mean? What does it mean? Okay, let us see the handout. Okay, page 2, problem 1. What is phenomenology? Okay, solution. The study of phenomena, which is equal to things that exist and can be seen, felt, tasted, etc., and how we experience them. Okay, let us go back to the slides. Okay, phenomenology of multipath channels. Okay, what are multipath channels? Okay, let us see the handout. Okay, problem 2. What are multipath channels? Solution. In radio communication, multipath is the propagation phenomenon that results in radio signals reaching the receiving antenna by 2 or more paths. Okay. Okay, next, second, we will introduce the power law propagation. Third, we will introduce impulse response of a multipath channel. Okay, what is the impulse response? Okay, if you have already taken the course Principles of Communications or Signals and Systems, okay, you should have learned what is impulse response. Okay, but I know some of you did not take the course Signals and Systems and Principles of Communications. Okay, so let me introduce what is impulse response to you. Okay, if you have learned it, you can treat it as a review of the impulse response. Okay, problem 3. What is the impulse response? Okay, solution. In signal processing, the impulse response or impulse response function, abbreviated IRF, of a dynamic system is its output when presented with a brief input signal called an impulse. Okay, then problem 4. What is an impulse? Solution. In mathematics, the direct delta distribution, also known as the unit impulse symbol, is a generalized function or distribution over the real numbers whose value is 0 everywhere except at 0, and whose integral over the entire real line is equal to 1. Please see figure 1. Okay. So let us see figure 1. Okay, this figure. Okay, figure 1 shows the schematic representation of the direct delta by a line surmounted by an arrow. Okay, you can see here is a blue line, okay, and with a circle at 0 and an arrow here. Okay, the height of the arrow is usually meant to specify the value of any multiplicative constant which will give the area under the function. Okay, usually if we are talking about the unit impulse, the area under the function will be 1. The other convention is to write the area next to the arrowhead. Okay, for example, okay, we can write 1, okay, beside the arrowhead. Okay. Okay, let us go back to the slides. Excuse me. Okay, first we will introduce intrinsic multipath channel parameters. Okay, what is intrinsic? Let us see the handout again. Okay, problem 5. What is intrinsic? Okay. Solution. Being an extremely important and basic characteristic of a person or thing. Okay, let us go back to the slides. Okay, fifth, we will introduce classes of multipath channels. Finally, we will introduce statistics of small-scale fading. Okay, what is small-scale fading? Okay, let us see the handout. Okay, problem 6. What is small-scale fading? Solution. Small-scale fading refers to the rapid changes of the amplitude and phase of a radio signal over a short period of time, on the order of seconds, or a short distance, a few wavelengths. Please see figure 2. Okay, figure 2 shows two kinds of fading. Okay, large scale fading and small scale fading. We can see that in this figure, the x-axis is time and the y-axis is signal power. Okay, there are two curves in this figure. The bold line is for large scale fading, this line. Okay, you can see that the signal power of the large scale fading varies slowly with time. Okay, And the gray line or the thin line is the small scale fading. Okay, this curve. Okay, you can see that the signal power of the small scale fading fluctuates rapidly with time. Okay, it is the small scale fading. Okay, first let us see the introduction. In the previous chapters, we examined some of the implications of the MIMO capacity formula. As we have seen, the statistics of the MIMO capacity are dependent on the statistics of the channel matrix and the average signal-to-noise ratio at the receiver, which we denote by rho. Both the statistics of H and the value of rho depend on the propagation characteristics of the channel. Thus, an understanding of propagation is important in order to predict and understand the performance of MIMO communication systems. Okay, because MIMO techniques are designed to operate in a scattering. Okay, what is scattering? Okay, let us see the handouts. Okay, page 6, problem 1. What is scattering? Okay. Solution. Scattering is a term used in physics to describe a wide range of physical processes where moving particles or radiation of some form, such as light or sound, are forced to deviate from a straight trajectory by localized non-uniformities, including particles and radiation, in the medium through which they pass. Please see figure 3. Okay, let us see figure 3. Okay, you can see that it is a beautiful photograph, okay, in the night, and there are many stars in the sky. Okay, figure 3. Though the echo light is a faint, diffuse glow visible in the night sky, the phenomenon stems from the scattering of some light by interplanetary dust spread throughout the plane of the solar system. Okay, so you can see that here. Okay, here is some red or orange. Okay, light here. Okay, and the echo light in Chinese, if it is translated in Chinese, is okay. Let I write it on the blackboard. Okay, it's this. 黄道光, okay, in Chinese. Okay, let us go back to the slides. Okay, because MIMO techniques are designed to operate in a scattering environment, we focus on channel phenomena that give rise to scattering and multipath. Without scattering and multipath, the channels between the various combinations of transmit and receive antennas are correlated, which results in poor MIMO performance. Okay. In this chapter, the fundamental concepts and terminology of multipath propagation are reviewed. Okay, so next let us go to section 4.1, Phenomenology of Multipath Channels. Okay, so it is 25 minutes. Let us take a break.